of Module 3, D.3, estimate the overflow bound in Project 1. In this part, I want to explain two methods. In our Project 1 description, you need to implement these two methods. The first one, using the Fibonacci numbers, the formula. We know that formula, so this is the formula. And the phi is the golden ratio. Okay? All right. So now we want to calculate the maximum n number in the project we call n max, such that when you calculate f of sub n max, there is no overflow. You can still find the correct answer. But if you just add one more number up on top of it, you will get overflow. Okay? So that's the number we want to calculate, the bound. All right. But how to calculate? How to use the formula to calculate without doing experiments. So this way you do not do experiments. Yeah. So here I give you the idea. Okay. Yeah. All right. First, here I use the Java example. Yeah. If some students, if you use Python, then you need to do simulation. Okay. Yeah. Python, you may need to do simulation. Yeah. All right. In Java, you can get the maximum, the largest long integer. Okay. So you have a way to get the, so first we need to get the largest long integer. Okay. Yeah, in Java, so we can get as a constant, some special constant, so you can get that. Okay. Yeah. But in Python, you have to do simulation. Okay. We know the largest long integer, 2 to the 64th minus 1. Yeah. Because 64-bit number. So that is minus 1. Okay. So that the largest is this one. Yeah. So you can calculate that, then you plug into the formula. So now let me use this number. We do the estimate. All right. In this formula first, let's look at this part. We know phi is greater than 1, right? So then the reciprocal of phi is less than 1, greater than 0. Okay? Yeah. So then 1 over phi to the nth power also between 0 and 1. Okay? So now let's do this. Phi to the n minus whatever it is. All right, okay. Less than or equal to, so actually less than, right? Yeah, we can see less than phi to the n plus 1, right? Yeah. So whatever it is, this whole thing, less than 1, right? Yeah, no matter it's positive, negative. Yeah, this is always correct. Yeah. So that tells us f sub n less than 1 over root 5 phi to the nth plus 1. How about that? So we get a simplified representation of the Fibonacci number. simplified, approximate, but it is a very close approximation. Yeah. Now we make, okay? So this time we make this. We make this, we force this less than that n max. How about that? This largest long integer. Yeah. All right. And we solve this inequality for this n. That will be our n max. Little n max. How about that? Little n max. We solve this equation using the logarithm. Can we do that? Logarithm. Yeah. Here, let me just do a few more steps. Yeah. For those who may not really familiar with the logarithm solving inequality, so here, let me just do a few more steps. All right. So starting from this formula, so we simplify it, we get phi to the nth plus 1 less than root 5 times n max. Right? Yeah. Phi to the n less than root 5 n max minus 1. Right? Yeah. Now we take a natural log both sides. N times natural log phi less than natural log root 5 n max minus 1. Okay, so then n n max minus 1 over natural log. How about that? Okay, less than. Okay, less than. All right. Okay, this expression you can calculate. You can use, math, methods in math. So in Java here, I'm talking about that, Java, math, some methods to do the calculation, right? Don't worry about the overflow in the calculation, because when you do calculation here, you use the double. Yeah, when you do this calculation, you use the double type. For the double type, the range much higher than the long integer. Much higher. So you don't need to worry about overflow for the double range. Because when you do calculation, you use double. Okay. All right. But after you get, so this expression will not be an integer. You just take floor function to get that largest integer. So yeah. All right. So just to write the final result, the floor function. So n max floor function root 5 n max minus 1 floor function. Okay, yeah. So in your program, you just do this calculation, okay, and output it and see what is that number. Okay, that is for method 1. Yeah. For students who use Python, you can do the simulation. Yeah. So your n max 2 to the 64 minus 1. That's your n max. Okay. Yeah. All right. Method number 2, we use a different way to estimate that number, but this time we need to do experiments, Fibonacci number experiments. Use the property of overflow. All right. Yeah, but when you use this method, try to use our efficient method, iterative efficient method. So it will be very fast. Otherwise, it will be too slow. So what is the property? So here I want to point out one property, overflow, related to overflow property. In my video, I talk about when you get overflow, there is no complaint. Okay? So in any computer, in Java, let's say, when you have a overflow, no complaint. Okay? No error message, nothing happens. Yeah. So you won't know if there is an overflow. So for that reason, we need to find a detection method. Overflow detection method. Okay. Yeah. How to do that? We need to figure out some special property so we can use. All right. So let me describe this special property. It is very simple. Now, when we calculate Fibonacci number, we just do addition, right? Simple addition. C equals A plus B. Yeah. A, F of F sub n minus 1. B, F sub n minus 2. And C, F sub n. Okay? So we do that. All right. So now, let me tell you the property. Okay. Now, under the normal condition, here I'm talking about the normal condition. Normal means no overflow. Okay. Normal condition. Under the normal condition, this equality is equivalent to B equals C minus A. Right? So from math, equivalent. Yeah. But it's true under normal condition. Okay? Yeah. But under the overflow situation, not true. Okay? So when you have an overflow, this won't be true. Okay? All right. So now, based on this observation, we design our detection method. Very simple. Our detection method. Okay? So here we consider the overflow situation. All right, yeah. Overflow situation. So we calculate C0, here, because when you do A plus B, eventually you will get overflow. So here I use C0 means the overflow value. That means truncated. The whole value you get overflow. The bits you need to use more than long integer can take. So those higher bits will be truncated. After truncation, I use C0 to denote that result. Yeah. So this means after truncation. All right. So now, because there is a truncation, okay? So now you compare B with C0 minus A. Okay? Won't be equal, okay? These two numbers won't be equal. No. Because after truncation, so you take C0 after truncation, then you minus A, definitely you cannot recover original B. So based on this property, you can detect overflow. Here I'm talking about Java. Okay, yeah. Because in Python, you won't get overflow. Yeah. Because Python already did that Java big integer idea using long string to represent number internally. So you are not aware of it. Okay? So For students using Python to do this program, skip this method. Skip this. You only do method 1. Skip this step. Okay? Yeah. Method 1 is okay. Yeah. You won't lose any point. You won't lose any points. Okay? All right. Yeah. So that's the detailed information about the project. Yeah. I already post the project description, so you can start working on it. You have 4 weeks to complete it. Yeah. You should have plenty of time. So the due date, October 27th, Tuesday. All right, yeah. Okay, so that's the video D.3.